All right, with number 3, we have more factoring to do before we can decide anything about this. Although we do know, since we have the same degree on the top and bottom, that we're going to take those leading coefficients, and those are going to be our horizontal asymptotes. So we'll go ahead and pull those right now. Easier to see those with the x squared over x squared. So that's our horizontal asymptote. Again, we're always writing that as an equation. Y equals, since it goes through the y-axis. If we have a horizontal asymptote, we don't have an open. All right, now I'm going to factor. So in my numerator, 2 times 4 is 8. Two numbers that multiply to 8 and add to 6 are 4 and 2. I always factor by split the middle because it's the same. It's every step is equal to the step before. If you're doing slide divide, I really suggest that you start working with split the middle or guess and check. I'm not picky about very many things, but you want to make sure that when you're factoring all of your, or when you're doing math, all of your steps are equal to the steps. All right, so 2x plus 2, I didn't even realize I could have taken out greatest common factor from the beginning. I'm going to go ahead and take it out at 2x plus 2. So that whole thing is going to become 2 times x plus 1 times x plus 2. The denominator is simpler to factor. I need two factors of -3 that add to -2. So my factors of 3 are 3 and 1, and to get -2 I need -3 and +1. So that gives me another piece of my puzzle here. X minus 1 is, or x plus 1 is going to be my removable discontinuity, which means that that is going to happen at -1, and I'll use my calculator to find that y value. Okay, other pieces that we know right now. The denominator here, our minus x minus 3, is going to give us a vertical asymptote at x equals 3. And we have one x-intercept, and it's at -2 from that x plus 2. I'm going to go ahead and plot what I have so far. So horizontal asymptote at y equals 1. Vertical asymptote at x equals 3. And of course, we'll check all of this on our calculator as well. X-intercept at -2, 0. And we have that removable discontinuity. We'll get that y value from our calculator in a minute. Okay, let's get our y-intercept, and we'll check that on, and then we'll start putting things into our calculator. So to get that y-intercept, again, you can do it purely from your calculator. I like doing the math as well. We're going to put in 0 for x, so 2 times 0 plus 2, and I always use the reduced fraction because it's the same everywhere except for at that hole. That reduced fraction here fills in the hole. So on the top I have 2 times 2, which is 4, and the denominator I have -3. So it's -1 1/3. Or -1/3. And we have a hole right in between those. All right, let's pull up our calculator and see if we can find a little more information here. When I'm graphing on my calculator, I'm going to put in the original function even before I factored, and I'm going to enter the reduced fraction so that I can get the y value of that removable discontinuity. So the first guy I'm entering here, 2x squared plus 6x plus 4. Oops, I missed that 4 there. And then the denominator, x squared minus 2x minus 3. And then my reduced fraction is this right here, 2 times x plus 2 in the numerator and x minus 3 in the denominator. Now when this graphs, it should graph right over itself, the blue and then the red, since I have a color calculator. And we can see it's the same everywhere, except when I go to the table, at -1, I have an error for my blue graph, that's my original equation, and the whole filled in with the red. So at -1, the whole is at -1, -1/2. So we can plot that now. And I'm just going to see if I have any other nice points I can graph between my y-intercept and that vertical asymptote. So between -1 and 3, I have 1, -3 and 2, -8. Those are nice points. 1, -3, 2, -8. And that's going to be one of the nicer curves we've ever seen there. On the other side of the vertical asymptote, I'm going to look for some points over there now. So it's going to be above 3. 4, 12 doesn't fit on my graph. 5, 7 does. And 8, 4 does. So 5, 7 and 8, 4 are the two I'm going to graph over there. 5, 7, 8, 4. What I like to, oops, that one, I made it at 4, 7. Should be at 5, 7. So what I'm going to ask for when you're graphing is two points on each side of your asymptote, at least. Usually your x-intercept and your y-intercept, are at least 2 of those. So if you graph at least 4 points, I think you'll get a nice curve in addition to everything. Okay, your domain here. Again, for the domain, we're going to exclude vertical asymptotes and x values of our removable discontinuity. So my vertical asymptote here is at 3, and my x value of my removable discontinuity is -1. So -infinity to -1, -1 to 3, and 3 to infinity. In set notation, x such that x does not equal -1, x does not equal 3. For range, we're going to exclude our horizontal asymptote and our y-coordinate of our removable discontinuity. So -infinity to -1/2, -1/2 to 1, 1 to infinity. And that in set notation y such that y cannot equal -1/2, y cannot equal 1. Lean on your calculator as much as you need to. Make sure that your graphs end up nice, that it matches what you see. And really, there's not much to fill in other than that. Use your calculator, graph your asymptotes. You got to know those rules pretty much now until forever. All right, that's number 3.